Hello everyone, I am Dr. Abha Kumari. Today our topic is non-homogeneous linear equation, non-homogeneous linear equation with constant coefficient. Fine, with constant coefficients. Earlier we have seen the type 4 problems in homogeneous linear differential equation of constant coefficient. Now, for this, let us consider an equation of the type d minus m d dash minus alpha into z equals to 0. Fine. So this is of the type p minus m into q equals to alpha z. And the form of this equation is like pp plus qq equals to r. And this is the Lagrange's equation. Okay. So here we use this equation to solve this differential equation. So the subsidiary equation are. So here we have p, then p minus m into q. So here q, both are q. So here it is m in place of q. So we will write it as like dx divided by p dy divided by q equals to dz divided by r. Okay, this is the equation we will solve. So therefore, from equation 1, we can write this equation as dx divided by 1. Why? Because we have p, but here p is not given, so it is 1. Now q is here, and what about capital Q? Q is m, so this is equals to what? Dy divided by minus m, and then dz divided by alpha into z. Here in place of r we have alpha z, so we will write it dz divided by alpha z. Fine. So now first two members. First we did the first two members. So what we get from first two members, we have dx divided by 1 equals to dy divided by minus m. And by solving this, what we get here is y plus mx equals to a constant. Fine. Similarly, by first and last, okay, from first and last member, what we get here is dx divided by 1 equals to dz divided by alpha z, and by integration this we have dx equals to dz by alpha z, and this implies x equals to what we have, x equals to, so here it is dz. So what we do is here x is equals to alpha x. We can take the alpha in the left hand side. Okay, so alpha into x equals to log z. Okay, fine. And then we have, say, some constant, say this one, say let us take the constant to be here, log b. Okay, fine. So here we have what, z into b equals to e to the power alpha x, and therefore z is equals to 1 by b e to the power alpha x. Fine. Therefore its complementary function is given by z is equals to e to the power alpha x. We just neglect this constant value, so we will write z equals to e to the power alpha x into, fine, into the first one is what, y plus mx in place of a. So here it is f of 1, fine, y plus m into x. So this is the CF when we have such this type of differential equation. Fine. So let us see in the extended form what we get if we have having the equation values or equation of the type such as, let us, in general we have the equation of d minus m1 d dash into minus alpha 1, fine, and then d minus m2 d dash minus alpha 2 and so on up to dot dot dot. We have here is and dot 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 d minus mn al d dash minus alpha n equals to 0. So if we have equation of this type, so that is what, how much roots are this? So there are n roots. Fine. So for n roots, how can we find the CF for this type of problem? So for this we will write the z as z equals to e to the power alpha 1x. Why? Because in the first factor we are getting the alpha 1 here. So we will write this alpha 1x into f1 y plus m1 x. Why m1? Because here it is m1. Second root is like alpha 2 in this way, in this from this factor. So we write like this, e to the power alpha 2x f2 y plus m2 x and so on. So in the last we are getting here as e to the power alpha nx fn y plus mn x. Fine. So this is our CF when we are having a distinct root. When we are having distinct root, that is our auxiliary equation, we are getting m different. But when case 2, when we have repeated factor, when we have repeated factors, that is the equation is of the type d minus md dash minus alpha to the power r into z equals to 0. So what we get here is, in each and every time we are getting this factor, how much times? So r times. So in this type of problem, that is when we are having the repeated factors, repeated roots. So here we will write the CF as z equals to e to the power alpha x, and each and every time we are getting an alpha x. Here we are getting alpha 1, alpha 2 up to dot alpha n, but here in this type of problems we are getting alpha r times. So we will not getting the right like this. We just write e to the power alpha x and then we have f of 1 y plus mx, right? Then since it is a repeated root case, so we will multiply by x and write e to the power alpha x and then f2y plus mx and so on, plus x to the power r minus 1 e to the power alpha x fr y plus mx. So this is the CF when we are having a repeated root. Fine. So this is clear to all of you. So next day we will see the particular integral of such functions.